All matter is made up of tiny particles called atoms. This is a visual representation of an atom. The center of an atom is called the nucleus, which holds the entire mass of the atom. The nucleus consists of positively charged protons and neutral neutrons. Protons and neutrons are the same size and each have a mass of 1 atomic mass unit. Electrons are extremely tiny, fast, negatively charged particles that orbit around the outside of the nucleus. Electrons are so tiny that they have a negligible mass, close enough to 0. This is a Bohr diagram, which is another type of visual representation of an atom. Here you can see that the tiny electrons travel in different energy levels. The electrons that are on the outermost energy level are called valence electrons. These are the very important electrons that are involved in chemical bonds. You can see that there are 7 valence electrons in this particular Bohr diagram. This picture is only two-dimensional and does not show the movement of these electrons. Here is a 3D animation of an oxygen atom showing the orbiting of the electrons at different energy levels. Keep in mind that this is only an animation. Real electrons move much faster than this, at nearly the speed of light, so fast that it would look more like a blurry cloud surrounding the nucleus. Now that we know what an atom's structure looks like, let's choose one of the first 20 elements on the periodic table and draw their atomic structure. First, we must look at the periodic table and pick an element. Let's choose boron. This is the information that the periodic table shows for boron. But what do these numbers mean? The top number is called the atomic number, which is equal to the number of protons. In our example, boron has an atomic number of 5, which indicates that there are 5 protons in an atom of boron. In a neutral atom, the number of protons is also equal to the number of electrons. So there are 5 electrons in a neutral atom of boron. The bottom number is the atomic mass. If you round this number to the nearest whole number, this is called the mass number. In this case, boron has a mass number of 11. The mass number is equal to the number of protons and neutrons in the nucleus. Remember that we already know that boron has 5 protons because the atomic number is 5. That must mean that the other 6 particles in the nucleus are the neutrons. So now we are ready to draw an atom of boron using the information. We need to show the 5 positive protons and 6 neutral neutrons in the nucleus. We also need to show the 5 negative electrons orbiting the nucleus in the different energy levels of the Bohr diagram. It is important to remember the 2882 rule for Bohr diagrams of the first 20 elements. This means that up to 2 electrons can fit in the first energy level. Up to 8 electrons can fit on the second energy level. And for elements 1 through 20, up to 8 electrons can fit in the third energy level and up to 2 on the fourth energy level. So, in our Bohr diagram of a boron atom, we have 2 electrons in the first energy level and 3 valence electrons in the outermost energy level. Remember that valence electrons are the electrons that exist on the outermost energy level. Practice on your own now. Draw the Bohr model of a potassium atom. Use the information from the periodic table for potassium. Write down the number of protons, neutrons, and electrons. Remember the 2882 rule when you draw the Bohr diagram. Show your teacher when you are done. Keep practicing. Practice makes perfect.